Okay, so in this lesson, I'm going to represent the domain and range of curves with one endpoint. So if you look at like example number 1 and number 2, they're both curves and they both like stop at a certain point. But then the other end, they just keep going. Now, the first thing that we'll do is talk about the domain. Remember, the domain measures how far left and right something is. So does the graph stop going left? Yeah, it does. It stops going left. It stops going left around -1, -2, -3, -4. Does it stop going to the right? No, it keeps going forever to the right. It's slanted, but it keeps going forever to the right. So what this means is that I'm going to have one sign. There's only one limitation on the x's, and it has to do with -4. So all these points are to the right of -4, so all these points are greater than -4. Can it ever be -4? No, because it gets close. I mean, you could try to argue that this is a point right here, but I was trying to make it get super close, but never quite touch. So let's look at the range. So the range measures how far up and down we go. Does the graph stop going down? Does it have like a lower limit? No. Does it stop going up, or does it have like an upper limit? Yeah, it has an upper limit. It is at 1, 2, 3, 4, 5, 6, 7, 8. It's like right here is the highest it goes. Yes, it stops going up at 8. Make that a tiny bit better. I am writing in white now for some reason. Okay. Let's try that again. Okay, cool. Now the y's in comparison to that 8, remember this is the one restriction we have with the y's, and that's the highest it goes. All the y's are lower than 8. And if we look here, we say, can it ever be 8? Yeah, I mean, remember, these are all points. That's the highest point, so it's going to be equal. Let's look at example number 2. So this one goes like that. Does this graph stop going to the left? No, there's no limit going to the left. Does it stop going right? Yeah, there's a limit. So the limit is at 1, 2, 3, 4, 5, 6. So remember, there's only one limitation on x, and it has to do with 6. If every x is to the left of it, then all the x's are less than 6. Can it ever be 6? Yeah, it can be 6. There's a point right there. Now let's start talking about the range, so how far up and down it goes. Does it ever stop going down? No. No limitations there. Does it have like a top? Does it ever stop going up? Yeah, it stops going up like right here when y is -1. So yes, when y is -1. So our one limitation has to do with, or our sole limitation has to do with this -1. Everything is below this, so all the y's are less. Like all these points right here are below -1. Can it be -1? Well, like I said before, these are all points. So that's a point. So less than -1. Or equal to. Okay, so let's look at example 3 and 4. So these look slightly different. So does the graph stop going left? Okay, let's talk about the domain first. I always gotta remind myself. Talk about domain, talk about left and right. Does it stop going left? No. Does it stop going right? Yeah. So 1, 2, 3, 4, 5, 6. I'll put 6 here. Okay, so it stops going. Oh, it gets really close to 6, but it never hits 6. So x, the only limitation is 6, and everything is to the left of 6, so everything is less. and it never touches that. That's never a point, so it never gets to 6. The range, which is how far up and down we go. Does it stop going down? Yes, it does at 1, 2, 3, 4, 5, 6, 7. This is the lowest it goes. 7. Does it stop going up? No. It just keeps going up forever. So we have one limitation on the y, on the range values. That has to do with 7. So all these points all have y's that are greater. Ooh. This whole time I've been saying 7. This is negative 7. This is negative 7. This is negative 7. So this whole time, all these points, right here, right here, right here, right here, right here, right here, and right here, right here, right here, all these have y's that are greater than negative 7. Ooh. The question is, can it be negative 7? Well, remember, that is a point, so it can be negative 7, so equal. Okay, so does the graph stop? Let's look at example 4. Does the graph stop going left? Yes, there's a limitation going left. At 1, 2, 3, 4, 5, 6, negative 6. Does it ever stop going right? No, it goes on slightly. I mean, it's kind of narrow, but it keeps going on. Or it's kind of steep. I mean, it's kind of steep, but it keeps going to the right slowly. So there's no limit there. So x, the only one limitation is negative 6. All the x's over here and continued are all to the right, so they are all greater. Can it ever be this negative 6? No, because that's not even a point. Let's think about the y values, the range values. Does it have a lowest? Does it ever stop going down? Yeah, right here. At 1, 2, 3, 4, 5, 6, 7. Oh, negative 7 again. And does it stop going up? No, it keeps going up pretty much forever. So the only limitation we have on y is negative 7. So all the points, well, I'm going to go back for a second because I don't agree with where I put that dot. It should be right here. Okay, so stops at negative 7. Y has to do with negative 7. All the values, all these points up here have y's that are greater than negative 7. That is a point, so it can be negative 7. Okay, next page. I'm going to attempt to do this a little faster. So does it stop going left? No. Does it stop going right? Yes, at positive 8. So the only limitation this graph has, or the x's have, is 8, and everything is to the left of that. So all the x's are less than 8, like this x and 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 this x even. They're all less than 8. Does the graph stop going down? No, it keeps going down. Does it stop going up? Yeah, it's like an upper limitation at 1, 2, 3, 4, 5, 6. So there's a limitation for the range values at 6. That is the highest, so they are all below it, so they are all less than. Can it ever be 6? Is there ever a point with y that's 6? Yes. And so let's look at this one. Example 6. Does the graph stop going left? No. Does it stop going to the right? Yes. The furthest right it goes is right here at 3. So the only limitation we have on the x values is 3. All the x's, like here, all these x's, like all these points, the x of all these points is to the left of 3, so they're all less. Can it ever be 3? Yeah, there's a point right there. Equal. So let's talk about the range. Does the graph stop going down? Yes. It approaches 1, 2, 3, 4, 5, 6, negative 7 again. All right. It approaches negative 7. Does it stop going up? No, it keeps going up. Slanted, slowly over time. So the only limitation we have on our range is -7. All these points and forever will be larger than -7. It never quite hits -7. It just gets super close, so it's not equal. All right, last two examples. So does it stop? Let's talk about the domain. Does the graph stop going left? Yeah, right here. At -10, I believe. Yep. But then it goes right forever. So does it stop going to the right? No. And the domain, so our x values are only limited by -10. All these dots here have an x that is bigger than -10, to the right of -10, or there's one, and there's one that's right at -10. Let's talk about the range. Does the graph stop going down? Yes, right here at -1, 2, 3, 4, 5. -5. Stop going up? No, it keeps going up forever. So we only have one limitation. So we know that the y is all the dots are above -5. So all the dots have a y that's greater than -5. And our last one. So does the graph stop going left? It does stop going left. At -1, 2, 3, 4. And then it keeps going forever, right? So there is no limitation there. So our x values for all these points, or this point, this point, this point, this point, this point, all these points right here, including this one and this one and this one and all the points we don't see later, they all have x's that are to the right of -4. So they all have x's that are greater than -4. And this point even is -4 for x. So equal. All right, our last one, our last range, and then we're done. So does the graph stop going down? No. There's no limitation. Does it stop going upwards? Yes. It stops near, well, the highest it goes is 0. This is 0 right here. So everything is below it. So everything's below 0. So all these points have y's that are less than 0, and it never quite hits 0. I mean, like, it looks like it gets really close, but it never quite hits there. And that is it. Thank you.